Okay, so now let's solve question 6, which is describe how the coefficients in linear regression are estimated using either the closed form equation or gradient descent. So let's see linear regression. Yeah. So linear regression is basically predicting a numerical value where we are ensuring that there is linear relationship between features and target vector. Here we model the relationship, that is, this is the predicted numerical value where B0 is bias or intercept, B1, B2 and up to BP are weights of to P features. Then we have X1, X2 up to XP, which is our features, and is the reducible or irreducible error, right? Here we want to estimate the coefficients B that minimize the residual sums of squares, right? We want to minimize the residual sum squares, that is the mean square error that or the least square principle. We try to minimize it so that we can get the best coefficients for our linear regression. Here we can either estimate our coefficient using the closed form equation or gradient descent. In closed form equation or normal equation, we have a matrix with a column of 1 for intercept and n into 1 vector for output. Here, this is the equation of the closed form. When we solve this, we will get the coefficients, right? After solving this, you get the coefficients, and but this is computationally expensive as it requires inverting the matrices, right? And if the features are more, this is more computational expensive and not that required or not that used, right? Here is the representation of linear regression. These are the data points, and here we draw a straight line which tries to uh, predict the numerical value. Here, now let's see gradient descent approach, in which for determining the coefficients, right? Gradient descent is first we initialize the coefficients randomly, then we repeat until here we are given W, which is weight, and B is bias. We calculate the partial relationship between the loss function. That is, we calculate the gradient and we go in the negative direction of gradients. We step back, we start from any particular point from a non-convex function and we go at the negative direction of gradient. And we repeat this until convergence is found or until uh, this is convergence is found and we get the best coefficient for our linear regression. Here we this alpha represent the learning rate. If alpha is more or large, then it will converge fast. If it is less, then it will converge slowly. But if alpha is large and it is converging fast, it does not always guarantees the convergence. So make sure you either estimate the learning rate using either cross validation or any other method, right? Now let's see second part of B part of the question. Explain logistic regression and use the logistic function to calculate probability of a class. Here logistic function is nothing but a sigmoid function which calculates the probability and gives the output as between 0 to 1. So now let's discuss logistic regression. Logistic regression is often used for classification. Here we use the log odd or log loss cross entropy loss function. Here relationship is same as linear regression, but this time we pass it on with x, where we pass it on in sigmoid function, which always gives value between the 0 to 1 in probability distribution. Right. Here we estimate our coefficient using by maximizing the likelihood function. This is our likelihood function, and which is nothing but sigmoid function. Here, right now, let's see a calculation where we will perform this linear regression. Let's take the bias B0 as -3. Let's take weight of first feature as zero point 0.1. And we take only one feature, that is age. Now, for person with age 40, we compute the linear score and the probability class. Based on that, weights and bias, we will put on this in the formula, which is 1 upon 1 plus e to the power -6. On putting this value, or in first we'll put this value in linear regression formula, and thus then this replace this value with x. Now we will get the value as 0.731, which is nothing but 73%. and we set a threshold as zero point 0.5 and above zero point 0.5. So when we are getting value above zero point 0.5, which is 73%, we accept this and we classify this as positive, right? This is basic logistic regression. I hope you understand it. If you have any doubt relating to this, please comment down, right? So this covers our question 6. Thank you.